Hi, my name is Matthew Anderson, and this is my lab for Physics 2, Lab 3 circuits. So the purpose of this lab was to demonstrate how currents and voltage in simple circuits function with ohmic resistors and capacitors, and to measure it using multimeters, specifically ammeters, and to use them to measure conventional current and the potential difference of circuits. So as a preview, the charge and discharge times for the capacitor were similar, but not exactly the same. They were close enough to demonstrate the principles, though. And the sum of the potential difference was 0.1, which should have been 0, but more on that later. And the resistors and wire had the expected um, resistance. So some of the fundamental principles, we had the node rule, which is basically a current conservation rule that current going into a point is the same as the current coming out of a point. We had the loop rule, which is more energy conservation. There should be zero potential difference for a complete loop. And then, of course, Ohm's law and the capacitance formula for finding resistance and capacitance in a circuit. So the first circuit was 2 ammeters, a 47 ohm and 100 ohm resistor in series, and then two 1.5 volt batteries. The whole circuit was the system. Everything else around it is the surroundings. And for this, it was to demonstrate the current going through both ammeters was read the same, 18.8, and it's conserved through each one. Then you can see the potential difference for the resistors is about expected. 47 is around half of 100, so 0.9 volts is just a little under half of 2 volts. And then for the batteries, the potential difference of each was negative 1.5 volts, and then together you had negative 3 volts. So that makes sense. And then for the diagram, you can see the potential difference goes up, and then once it gets to a resistor, it goes down. Then for the RC circuit, the system is the entire circuit once again, and then there is a 20 ohm bulb, a 1 farad capacitor, and two 1.5 volt batteries again. And we had to observe the capacitor charging and discharging, and time it with a stopwatch. And we saw the charge and discharge times were roughly similar, pretty close, and close enough to demonstrate the fundamental physics of the circuit. Any differences between them were likely due to the equipment being kind of malfunctioning or just user error. And for the what if you charged a capacitor with no resistor in the circuit, how quickly would the ideal model predict the capacitor to reach full charge, and would this happen in real life? So in theory, the capacitor in the ideal model would charge instantly since there's no resistance. In reality, there's always some internal non-zero resistance, even if there's no explicit capacitor in the circuit. There's going to be small resistance in the wires and the batteries, so it would not instantly charge in real life, but it would be expected to be pretty quick. And that's all I have.